Okay, hello everyone. This is the last section in chapter 7 as an application on Laplace transform. We will use Laplace transform to solve a system of initial value problems. Before we said initial value problems for this using Laplace transform. So let's go with the word system. System means you're going to have more than one equation. So more than one equation. One equation. When I say equation, I mean differential equation. More than one differential equation. So here, I'm giving an example right away. So I have two differential equations. So here we have two differential equations. Yeah, two differential equations. The variables here, the dependent variables are x and y. So we are looking, so we are solving for x and y. Of course, x is a function of time and y is a function of time. This means that x is a dependent variable and y is a dependent variable, and t here is our independent variable. So we are not looking for one dependent variable this time. We are going with two dependent variables together. Now why together? Because these two equations are connected. So in the equation for x, this is equation for x, you have the derivative for x and you have x, but you have y here. And in the equation for y, you have the derivative for y, you have y and you have x. So these two equations are connected equations. So you cannot solve one equation alone. You need to solve the system of equations. I think for this question I forgot the initial conditions, which are y of 0 is 1 and and x of 0 is also 1. So we have here y of 0. So for that equation x prime equal 3x minus 2y, we have one derivative, then we need one initial condition. So we need x at 0, right? It says x at 0 is 1. Now also this is a differential equation. You have the first derivative, then you need one initial condition, then you need y at 0. It is also giving me y at 0 equal 1. So this guy, so this equation has this initial condition and this equation has that initial condition. The full system here, the full system, so we call this system of initial value problems. Yeah, system of initial value problem. Yeah. Now how to solve this system? Nothing new. For this reason I'm writing the question right away. So I'm going to show you how to solve this system, how to find x of t and y of t. Yeah. So let me go back to the system here, and then I'm going to just write the initial condition right there. So here is x of 0 equal 1 for that one, and y of 0 equal 1 for the second one. Now what I'm going to do to solve this, I will take the Laplace transform for each of the two equations. So Laplace transform of this equation and Laplace transform of this equation. Yeah. Then I will change this system to a system of algebraic equation. So I will go back to linear algebra after this step. So I'm changing from, so here it is not clear what is the independent variable, but usually when I say x prime, I mean dx over dt, and y prime, I mean dy over dt. Here it is not clear that the independent variable is t, but when there is no independent variable, I will assume it t. Now this is a time domain differential equations. I will change them to frequency domain. How am I going to do that? Laplace transform for the first equation. Now we know that for the derivative, I'm writing y here, but it is x prime. I'm going to have for the first one here, now I'm doing the solution. I will change the color. So I'm changing the color, the solution. So the first equation is here now. First equation is there. So I'm going to have the Laplace transform for the first derivative for x equal to the Laplace transform. So I'm using linearity here. It will be 3 Laplace of x minus 2 Laplace of y. Now I will assume that the Laplace transform of small x is big X of t, x of s. And then I'm going to have 3. So the Laplace transform of x is big X of s, and the Laplace transform of small y is big Y of s. And we have that 2 here. Okay. Now what about this one? There is a rule for this one. It says for the derivative you will have s big X of s, yeah, minus x small at 0, yeah. Now do we have x small at 0? Yes, we have this, so this thing gonna go there. And the first equation now for x, the equation of x will be s x of s minus 1 equal to 3x of s minus 2y of s. This is the first equation. This is the first algebraic equation. Even I need to, I will maybe make it nicer. I will just arrange the x's in one side. So for example, I subtract 3x's from both sides. Yeah. And I add 1 to both sides. Yeah. And also I need to take also the y's to the other side. So I will use another color for this. I will add here 2ys. And I will add here 2ys. And then the equation will be the following now. What is going on here? So all that thing down will be, here is the first equation, will be s and minus 3. So you're going to have s minus 3 xs, right? I'm just collecting the x's, so I'm collecting that x with that x in one side and even taking xs as a common factor. And the 1 goes to the other side, but plus 2. So we're going to here have 2y of s, and equal in the other side I'm going to have just that 1. Yeah, this is just the Laplace. So this equation here, it is giving me that thing. Yeah, and let me go with the other equation, which was sorry, maybe I erased that equation. It was 3y minus 2x. The other equation is the Laplace transform of y prime. It should equal to the Laplace 3 Laplace transform of y minus 2 Laplace of x. Yeah, and again this thing we call it y big of s, and here's the 3. And here is minus 2x of s, and in this side you use the Laplace transform for the derivative. Then you're going to have s y of s minus y small at 0. Y small at 0 is 1. So I'm using the initial condition now. This is given in the question, it is 1. Now again I need to make this nicer, so I will subtract 3 ys from both sides, minus 3ys, and I also add 2xs and 2xs to both sides. So plus 2xs 2xs and plus 2xs, and also I will add 1 to both sides, and then finally I will have another nice equation. So I will write it in green, so because the two green will be solved now. The second one will be, so here is s minus 3, so I'm gonna have s minus 3, and then let me start with x. It's better to start with x because here we have x and then y. Then let me start with the x first, then I'm gonna have 2xs, yeah, and then I'm gonna have what? I'm gonna have s minus 3 ys, yeah, and then equal to 1. Now let me just show you what we have. We have this equation and that equation. I will write them beside each other and I will try to solve them. So this is the Laplace transform for the second differential equation, which is the equation for y, because y has a derivative in that one. So here we have 2, and here we have 2xs, and here we have s minus 3 ys equal to 1. So this is equation number 1, the Laplace transform for the first equation. This is the Laplace transform for the second equation. Now I'm solving now in the s domain or in the frequency domain. So I'm looking for big X and big Y. So I'm looking for big X and big Y. Then I will look for small x of t and small y of t. Now, how to solve this? Now suppose that I want to get rid of x or get rid of y. Let me decide. I'm gonna decide to get rid of x. So I need to get rid of x. How? I need the same coefficient here and there with different signs. So let me go with the first equation. I multiply it with minus 2. Yeah? Minus 2 times the first equation. And the second one, I will multiply it with s minus 3. Yeah? S minus 3. Then what I'm going to have here, I'm going to have minus 2, s plus 3, x of s. This is the first equation here. Yeah? And then minus 4, y big of s equal to minus 2. And the second one is 2 s plus 3 x of s. This is a big x, right? And then here you're going to have s minus 3 squared. S minus 3 squared equal to s minus 3. Yes, so squared s minus 3. Now adding this together, this is what we want. We want to get rid of that x with that thing, and then I have one. Now I have only y of s to look for, so I'm gonna have something like s minus 3 squared. Sorry, I forgot y of s here. Y of s, yeah, equal. Now this minus 4, so I'm just adding or regrouping these two things and taking y of s as a common factor, right? So I'm taking y of s as a common factor, taking y of s from the second one, then you have s minus 3 squared, and taking y of s from this one, you get minus 4. If you multiply it out again and expanding the bracket, you will have that and that. Now on the other side, you're gonna have, I'm gonna keep it s minus 3 and minus 2. There is a reason why I'm keeping this. I will tell you later why I'm keeping this. You will discover that after the next step. Now if you are looking for y big of s, then it is s minus 3 minus 2 over s minus 3 squared minus 4, right? So it seems to me that this thing and that thing are related to each other. So I need to factorize, maybe I need to factorize the denominator. Before doing the Laplace inverse, so I got the solution for y, but in the frequency domain. Now before doing the Laplace inverse, I need to simplify. It's better to simplify. Then this thing is a full, it is kind of, it is a squared minus squared. So this thing is kind of 2 squared, right? So I'm gonna make a bracket here and factorize the denominator. Then I'm gonna have s plus 3 and here s plus 3, and I'm gonna have the 4 is minus 4, then you're gonna have plus 2 minus 2, and up here you have s minus I think, yeah, s minus 3, and then here minus 2. I think here we have s minus 3, s minus 3, yeah, s minus 3. So s minus 3 times s minus 3 squared, and 2 plus 2 times minus 2 is minus 4 squared. Now you can simplify now this thing with that thing, and you ended up with 1 over this thing. Now I don't need anymore to keep them minus 3 and 2. I'm gonna make it minus 3 and minus 2. I make it minus 1. So I got y of s, it is 1 over s minus 1. Now if you want y of t, then you need to do the Laplace inverse for this thing, and you know for this thing you go to line number 3. So using line number 3 in the table, then you're gonna have 1 over, it's clear here that your a is 1, right? Your a is 1. Then here you're gonna have e power at, then you're gonna have t, right? 1t. So I got y of t here. So but when you solve a system, then you don't look for one variable, dependent variable, you look for both x of t and y of t, because these two are related solutions. Then now you need now to look for x of t. So what is x of t? Now let me go back to the equation. So we know from the first equation, so from the first equation in green, if you go back to the equation in green, it was s minus 3 and x of s, right? X of s plus 2 y big of s equal 1, right? But now we know this thing, right? We know this thing. What was this thing? Now we know this thing. This thing was here, y big of s. It was 1 over s minus 1, right? So you take that thing and you plug it here, right? Then you have s minus 3 x of s plus 2 over s minus 1 equal 1. Now you are solving for big x of s and then for small x of t. Now first of all you subtract 2 over s minus 1 and from both sides. Yeah? Then the next step, here, so what you are getting is s minus 3, and here on the other side times x big of s equal to this thing, the 1, I can consider the 1 as s minus 1 over s minus 1. Yeah, s minus 1 divided by s minus 1 and minus 2 over s minus 1, right? Yeah? Then in this case, so this thing is the 1, right? This is the 1. And in this case, you're going to have s minus 3 over s minus 1, right? Now again, if you solve for x of s now, So solving now for x of s, x big of s, again you need to divide that equation. So now the next step here is to divide that equation over s plus or minus 3, s minus 3, s minus 3. Then what you're going to have, again you're going to have 1 over s minus 1, right? Because this thing with that thing will cancel, right? So again you're going to have this. Now taking the Laplace inverse now to get the time solution, then you get x of t. X of t is just e power a, here again is 1, and then you get et. So I'm using again line number line 3, yeah, line 3 in the table. Now what is the solution? Now solution for the system is x of t y of t equal to et and et. Both of them, both x of t is e power t and y of t is e power t. Both of them are e power t, e power t. Let me solve another question for you. I'm going to solve question number 5 now in the book. Here is question number 5. It is x prime equal to y plus sine t and y prime equal to x plus 2 cosine t. And this is a system because you have more than one dependent variable and they are connected because the equation for x is or having y and the equation of y is having x here, right? But the good thing now, we know what is the independent variable. It is t here, yeah? This is x prime, y prime, so you have x as a dependent, y as a dependent, you have t here as independent variable. For each of the equation you have here first derivative, then you need one initial condition. And for this one it is first derivative, then you're going to have an initial condition. So you're going to have this is 2 and this one is 0. Yeah? Again, it is the same procedure that you're going to do always. If you are doing a solution for a system, then you are looking, remember that you are looking for x of t and y of t. Yeah, you need both because they are depending on each other. So it is a solution for a system. So two things together are solving the system. Now, the first step is taking the Laplace transform of both equations. Yeah? Now we know that the Laplace transform is linear. Then you're going to have Laplace of x prime equal Laplace of y plus Laplace of sine t. Yeah? This is the first equation. And let me simplify this. This is the first equation here. Then you're going to have here, this is the rule for the Laplace transform of the first derivative. You get s, x big of s minus x small at 0. And here we call the Laplace transform for y, big Y of s. And that thing we can go to the table right away. This one you go to the table, which line? Line 4. Line 4. And your b here is just 1, right? Then you're going to have here 1 over s squared plus b squared. B squared is 1 squared, 1 squared. So you get just 1. Yeah? Yeah, it is b over, sorry, it was b over b squared. Then you have b is 1, then you get 1 and 1. Yeah? Okay, and also that too should go here for x of 0. So this thing is 2. Now you need to rearrange the equation, so x first, then y, then the rest are on the other side. So we have the first equation here, s x of s, and you know the story, you subtract y of s from both sides, then you get y big of s, yeah? I subtracted this, or I moved this to the other side. And this 2, you add 2 to both sides. Just to tell you, I'm adding 2 to both sides, yeah? And I'm subtracting y of s from both sides, yeah? This is what I'm doing. Then I'm gonna have this, and on the other side, I'm gonna have 2 over 2 plus 1 over s squared plus 1. Now, till now, I'm not sure whether to combine the two parts here or to keep them. Let's keep them as they are. If I need to make them one fraction, I will do that later. Now, let's go with the second equation. Now, let me do this one in green. So this one. So you're gonna have the Laplace transform of y prime. Then you're gonna have s y big of s minus s of 0, right? And then equal on the other side, Laplace transform of x small, then it is x big of s, and then Laplace transform, so you know I'm doing the Laplace transform, and then Laplace transform, and I take the 2 out of the Laplace because it is linear. Then here is the 2, and then the Laplace of cosine. So if you want to do the cosine here, then you go to line here, line number 5, right? And still b is 1 here, then you get here s over s squared plus b squared is 1, right? Now again, I know what is that thing. I know what is, this is not s of 0, this is y of 0, yeah? This is y of 0. Now this is 0, now this 0 comes here, and then I have this to be 0, right? Okay, now rearranging, again you're gonna subtract x of s from this side and x of s from this side, and then finally you get s y of s minus x of s equal to 2s over s squared plus 1. Good? Now we have 2 equations to solve. Let me show you the 2 equations. This is equation number 1, yeah, and here is equation number 2, and these equations are living in the S domain, right? Then you solve them in the S domain, and then you translate or you do the Laplace inverse for both of them to the time domain. So let's keep them till I copy the 2 things here. Just let's have a plan now, what we're gonna do with them. Now let me look at this one. Let me look at the red one here, the red one. So let's, maybe it's better to have the x before. So I'm gonna have the x here, right? So this is x. I need to have the x before. So here is the x, yeah. Here is the x, yeah. And here is the s, y, s. So I need to keep them in the same order. It's better to keep them in the same order so that you can track your work. So we have minus x of s, yeah. And we have here s x of s. Now if you want to, so this is the equation number 2, and this is equation number 1, right? Equation number 1 here. Now suppose that you want to get rid of x. Then you need to multiply the second equation with s. Then you're gonna have s x of s and minus s x of s. So let me just write this. So I'm multiplying here. So I'm multiplying that equation with s. Yeah? And now if I multiply this with s and I write the equation here, then I'm going to have minus s x of s, and I'm going to have plus s squared y big of s, and then here you're going to have equal to, now multiplying with s you get 2s squared, right, over s squared plus 1. Good? And now I'm writing the second one, which is this one. I will keep this red here. I will keep it red. So I have x of s. And then here we have that s, y of s. And on the other side we have that thing, which is 2 plus 1 over s squared plus 1. Good? Now adding these two together, then it is clear that this two will cancel each other. Yeah? So I'm multiplying with s, I'm getting s squared, right? So I'm getting s squared. S squared here minus, sorry, it is up here. It is okay. It is okay. So it is okay. So the other one, this one is that they're not okay. So this one, I'm just copying this. So this is the part, this is the part, this is the 2, this is the 1 over s squared plus 1. Now adding these together, then you're going to have s squared minus 1. So I'm grouping. So taking y of s as a common factor here. Then from the first one you get s squared, from the second one you get minus 1 here. And then this will equal to, now I'm going to keep the 2 here for a moment, and when you add this to that, then you get 1, so this is a common denominator, right? Then you get 2s squared, 2s squared over s squared plus 1. So I group these two, I group them here. 2s squared over s squared plus 1, and here is the 2. Now the next step will be just to divide the whole equation by s squared, divide the whole equation by s squared minus 1. Then I'm going to have y big of s, yeah, y big of s equal to 2 over s squared minus 1 plus 2s squared over s squared plus 1 times s minus 1. Now we need y of t. You know, if you need y of t, then you need the Laplace inverse, so y of t now. So from here to there, you do the Laplace inverse, right? Laplace inverse. Then you need the Laplace inverse of this one. But this one is never in the table, because in the table you have always plus, s squared plus. If it is minus, then you need to do partial fraction. So I'm going to write this s minus 1, s plus 1. Yeah? And then we have the Laplace inverse for this one, right? And the other one is also, sorry, s squared minus 1 here. The other one is Laplace inverse of 2s squared over s squared plus 1. And then we have s minus 1 and s plus 1. Yeah? Now you need to do partial fraction here and partial fraction here. I will do the partial fraction now. So you have 2 over s minus 1 and s plus 1. So I'm doing the first part, which is this part. So here, partial fraction for the first one, it will be a over s minus 1 plus b over s plus 1. Yeah? And then this thing will be just a times s plus 1 and plus b times s minus 1 over s minus 1 and s plus 1. Now it's clear that 2 will equal to a times s plus 1 and plus b times s minus 1. Now the first thing, you take s equals 0. Sorry, I take s maybe equal minus 1 better. Then you kill that thing and you get b equal to minus 1. Yeah? And if you take s to be 1, then you kill that one and you get a equal 1. Yeah? A equal 1. And finally, I got the Laplace inverse of 2 over s minus 1, s plus 1. It is the Laplace inverse of what? A over s minus 1, so you get 1 over s minus 1. So this is the a, yeah? And then I'm using, so we know this, it is 1, we know this, it is minus 1. Then I'm using the linearity for Laplace inverse of 1 over s plus 1. And then you get, now because it is minus here, when you go to exponential you make it plus, then plus 1t. And the other one is just because it is plus here, when you go to t you make it minus. Yeah? So I got just that part. Still you didn't finish y of t. We got one part of y of t, we need the other part for y of t. So let me go for the other part for y of t. So I'm done with this part. This is the second part for y of t. It is the Laplace inverse. It is the Laplace inverse of, so this is the second part. So first part for y of t. The second part is to do now this thing. Now I'm doing this, 2 over s squared over s squared plus 1 and s plus 1 and or s minus 1 and s plus 1, yeah, equal to as plus b over s squared plus 1, because this is irreducible, so it is quadratic, then you have linear here, plus c over s minus 1 plus d s plus d divided by s plus 1. And then again, if you wanna do things right, then 2s squared will equal, you make a common denominator, you will discover that this will be asb times s minus 1 times s plus 1, and then plus, so we don't need this anymore, right? We don't need this anymore, plus c s squared plus 1 and s plus 1 plus d times s minus 1 and s squared plus 1, right? So here is what we have. Now going one by one, taking s equal 1, then you get here in this side, so let me write here, s equal 1, then this side will give you 2, but that side will kill this, you will kill that, and you will get here 2 plus 2, 4c, then you get just c equal half. And then again, if you go with s equal minus 1, then this side will be 2 again, this side will be 0, this side will be 0, this side will be minus 4, right? So it will be minus 4, yeah? Because we have minus 2 and 2 there, minus 4 d, and then d, sorry, here d equal minus half, yeah? And now more, we can go more with, for example, if you go with s equals 0, then you're going to have 0 in this side, and in this side you're going to have b times 1 times minus 1, then you're going to have minus b here, yeah, because this is minus 1, 0, 0, minus 1, and this is 0, you get b minus b, and here you get c, and here you get minus d, right? And if you want to look carefully here, you are solving for b, right? Then b will equal to c minus d, then you will discover that c minus d, then your b will be 1, yeah? And then if you solve for A now, if you solve for A now, how you gonna find A? You can go with a trick like go with comparing, I will compare the coefficient of S cube, for example. So here you're gonna have 1, if you multiply this, you're gonna have AS cubed here, yeah? And you're gonna have from this, you have 1 CS cubed, yeah? And you're gonna have also here plus DS cubed, right? But in that side you have no S cubed, 0 S cubed, because you have only quadratic, right? Now in this case you have A plus C plus D equals 0. Now C plus D is 0 already, then you discover that this is half, this is minus half, this is A, this is 0, then A is 0, right? Then what we got here, I'm gonna show you what we got. We need this, yeah? Yeah? Yeah, we have the C. Yeah, we have the C to be half, the D to be minus half, the B to be 1, and the A to be 0, right? So we don't have this. Now, if you want to do the Laplace inverse, now what is the Laplace inverse of that thing? It is the Laplace inverse of this thing, which is, if you go and compare with sine, then you will discover that this thing is just sine t. Now, if you do Laplace inverse of the first one, the Laplace inverse of the second one, and the Laplace inverse of the third one, yeah? Laplace inverse, Laplace inverse, Laplace inverse. So this one give you sine t. This one, you take the half outside, this is plus half, and the s minus 1 give you et, right? Minus become plus, and here we have the minus half outside, and the plus become minus in this thing, right? So this is the second part for y of t. If I still remember, y of t is supposed to be 2 parts. The first part give me et plus e minus t, and the second part is giving me sine t plus half et minus half e minus t, right? In other words, if you want to just this thing collect or regrouping things, then you're gonna have 3/2 et, and then here you're gonna have half e minus t. Yeah, I'm just regrouping this with that, so you have 2/2 here minus 1/2, or 1 minus half. You get half e minus t plus sine t. Are we done? No, we are not done yet, because we got y of t, and for a system we have 2 things to calculate. One of them is x of t, one of them is y of t. Now I will leave it as an exercise. So as an exercise for you, go to the equation for x of s, equation for x of s, and y of s for x of s, and you plug here, plug in y big of s, and then solve for x of s, and then you do the Laplace inverse of the equation for x of s to get x of t. And the final thing is just to see that the solution for the system S, and you write here x of t, whatever you're gonna get there, whatever. So you get this here, so I'm gonna assume that you're gonna get that here, yeah. And then we have also here the y of t, right? So we have two solutions. So we have y of t and x of t. So I'm gonna assume that you get x of t and we have the y of t already. So this is the solution. The solution. Yeah. For the initial value problem. Okay, by this we reach the end of today's lecture. It is a very short section, but the calculation are very long, so I will say see you next time in another video next week. Thank you very much.